Hey there, welcome back. So this is your Amandeep Singh, and today we'll be continuing with the series which we left a few days back. That was 100 days of transforming your thinking in graphs. So in this video, we'll be solving the next problem in that series, and the problem name is minimum number of vertices to reach all nodes. This is problem number 1557 on lead code medium tag problem. So we will solve this problem in this video, so stay with me and let's start with the session. Hey, welcome back. So this is your Ramandeep Singh, and today we're going to be solving this problem in this series of like 100 days of transforming your thinking into graphs. So in this video lecture we'll be solving this problem, which is minimum number of vertices to reach all nodes. So what we have in this problem, let's read it. So given a directed acyclic graph with n vertices numbered from 0 to n minus 1 and an array edges where edge I is a pair, give a pair of two nodes where the first node is the starting node and the second node is the ending node, represents a directed edge from to node 2. So from is the starting node and 2 is the ending node. Find the smallest set of vertices from which all nodes in the graph are reachable. ठीक है. It's guaranteed that a unique solution exists. Notice that you can return the vertices in any order. So what do you have to do in this problem? The problem statement is simple. All we have to do is we have been given a graph and the graph is acyclic. So there is no cycle in the graph. So once we start from a particular node, we will not come back to that node after completing a cycle. So there is no cycle in it. It's a acyclic graph. And the number of nodes are n. They are numbered from 0 to n minus 1. What we have to do in this problem statement is to return the set of vertices or set of nodes from which all other nodes can be reached. Okay. Like let's take this example 1 0 2. So let's move to the board. So we have this example 1 ठीक है. So we have this is 1 and then we have this 0. This 1 can be reached from 0. ठीक है. Then we have this 2 which can be reached from this 0, and then we have this 4 from which we can reach this 2, and then we have this 3. Then from this 2 we have this 5. ठीक है. So let's see what we have here. What are the set of vertices from where I can reach all other vertices? So I can see that this is one of the vertices. This is vertex numbered 0. From here, from 0 I can reach vertex 1, I can reach vertex 2, and I can reach vertex 5. Then from this vertex, which is vertex 3, so from vertex 3 I can reach 4, I can reach 2, I can reach 5. Yeah. So I can see that these are the two vertices from which I can reach all other vertices or the rest of the vertices that we have. So the answer would be this set 0, 3. That's my answer. And I'll have to return it in the list format if I'm not wrong. Yes, list format. Cool. ठीक है. So that's what we have to do in this problem statement. I hope the statement is clear. Let's take one more example. 4. Let's take this example 4. Then we have this 2. Then we have this 1 here. Then we have this 0 here, then we have this 3 here. So from 2 to 1, from 2 to 4, then from 1 to 4, then from 0 to 1, then from 3 to 1. So this is you know uh, this is the graph that we have, okay? And we can see that from this vertex, which is vertex 2, I can reach vertex 4, I can reach vertex 1. So from 2 I can reach 1, I can reach 4. From 1 no, not this is the first vertex, and then what other vertex do we have? 1 4 has been visited. Then from 0 I can visit 1, okay, ठीक है. From 3 I can visit 1, 4 has been visited, 1 has been visited, 0 and 3 are not visited, ठीक है. And there is no way to there is no way to visit 0 and 3 except we visit them separately. So I visit 0 and then I visit 3. There is no other way. You can see I cannot reach 0 from any other node, I cannot reach 3 from any other node, है ना? So the set would be this: 2 0 3. 2 is also I cannot reach from any other node, ठीक है. 2 0 3, yeah, 0 2 3. So the solution will be clear to all of you. We can see that 0 has 0 in degree. In degree is 0 for this node. In degree is 0 for this node as well, ठीक है. In degree is 0 for this node as well, ठीक है. So let's count the in degrees. The in degree for this is 0, the in degree for this is 0, for this it is 1, for this it is 2, for this it is 1, and for this it is 1. We can see that the answer has in degree of 0. Now here let's again write the in degrees. For this it is 0, for this it is 0, for this it is 0, for this it is 4, and for this it is 2. So we can see that all the nodes with 0 in degrees are my answer nodes. So all nodes with in degree 0 are my answer nodes, ठीक है. So I hope you learned something from this example, and let's write the code for this. So all we have to do is to just check the in degree. So just in this function find smallest. So in this function which is find smallest set of vertices, and inside it what do we have? We have edges. Just check the in degree for each node, ठीक है. So create an in degree array, and the size would be n for that array. Iterate over the edges for a comma b in these edges that we have. In degree for b will increase. Now simply iterate over this in degree array for I in range, let's say n, because vertices are numbered from 0 to n. If you find in degree for any vertex to be 0, then that's your answer, ठीक है. that's in your answer set. Dot add that vertex. So also declare an answer array. Finally you return that answer. ठीक है, हो गया. So that's all we have to do in this particular question. Just count the in degree. So let's move to the code implementation part. So let's first create a list of integers. Let's call it answer. New array list, and then what do we have after that? Let's create a visited array. Int visited new int n. ठीक है. Then for integer edge in the edges visited e dot get 1 would be what? Here I am going to add 1, है ना, because that's the in degree I am counting. Let's iterate over the nodes, and if I find the in degree for any, let's say, node I to be 0, that node I am going to add in my answer, and at the end I will return answer. Cool है. So let's submit it, and ठीक है. So that's all for this video, and I hope you learned something out of it. This is just a simple yet another simple problem where we had to count the in degree, है ना. So there is a concept of in degree, how many edges are coming towards a node, and there is a concept of out degree, how many edges are going out from a node. ठीक है. So here we just had to count the number of nodes which are coming towards, the number of edges which are coming towards a node, that is called in degree, and just push all the nodes with in degree 0 in an array and return that array. That would be my answer. The set of all such nodes will be my answer. ठीक है. So that's all for this video. What's the time complexity for this? Of course it's linear, because we are just iterating over the edges and we are iterating over all the nodes. ठीक है. And what is the space complexity? What is the space complexity? Now, actually the time complexity would be big of e plus big of n, or big of e plus n. Why? Because we are iterating over the edges and then we are iterating over the nodes. So it would be actually big of, now edges can be far more higher than the number of nodes in some cases, like we have a complete graph where we have n square order of edges, while e is less than equal to n for some cases, like a tree where we have only n minus 1 edges. So this would be the correct time complexity for this particular solution, and yeah, that's all for this video. And what's the space complexity? Of course it's big of n, because I'm declaring a visited array here. Okay. And yeah, that's all for this one, and I will see you in the next one. Bye bye.